Okay, so we're going to take a look at Newton's method. This is the formula for Newton's method. Now I know you have no idea where this comes from right now, but we'll talk about where it how it's derived, and basically first let's take a look at the idea, the big picture. Let me show you a picture of a function. So this guy right here is let me draw it over here. Okay. So the idea looks something like this. You find the you pick a point, a guess point. So let's say for example, we're going to use an easy one, x equals 1. Now the closer you are to the actual point, the better, but of course if you have no idea, because maybe you don't have a picture or something, then any point would be appropriate. So you find the tangent line at that point. So for example right here, we would find the tangent line here. And so the tangent line would look something like that. Once you do that, you find the point where the tangent line crosses the x-axis. So you find the x-intercept for the tangent line, which would be easy to do. And once you do that, let me show you another picture. And so notice, so right here you find the place where it intersects, right there, and that would be your approximation. So here, notice that this is an iterative process. Your guess is going to be, let me label these. So your initial guess is x sub 0. And then your next so your first x-intercept would be called x sub 1. So that's why it goes up on the formula 1 every time. And then what you do is you use this as your next spot to find the tangent line, and you repeat. So for example, right here, this spot, which is x sub 1, you would go up to your function, and right here you would find then the tangent line again. And then this time, this value right there, this is going to be your x sub 2. And notice how x sub 2 is much closer than x sub 1 to your actual root. And so that's the process, and this is the formula that gives you each iteration every time. Okay, so now let's talk about how to derive the formula. Okay, so let's remember that the equation of the tangent line, so normally we tend to write it as y equals mx plus b. But let's take a look. Let's write it down in the other form, in the point slope form. So you would have y minus y1 equals m times x minus x1. Let me bring back my picture. Okay, so I'm going to rename these. I'm going to rename y sub 1 and x sub 1. These correspond to the values where I'm finding my tangent line. So for example, in this one, when I did when I let x equal to 1, then that was my x sub 0. So I'm going to call this guy x sub 0, and y sub 1, I'm going to call that f of x sub 0. Then the slope, m, that, remember, is the derivative at x sub 0. So everything is going on at x sub 0 because that was the value that I used to find my very first tangent line, which in this case was 1. So remember, this guy was x sub 0. Okay, so I'm going to rewrite this. I'm going to have y, and then I'm going to bring the f of x sub 0 to the other side. So I'm going to have y equals to f of x sub 0 plus f prime of x sub 0 times, I'm going to leave it blank here, and for x, because I'm going to point something out right now. Okay, so x here represents the x value on the tangent line. And so what that is what I want to do is, since I'm looking for this value right here, I'm looking for the x-intercept, right? So the x-intercept happens when y is equal to 0, and it's going to give me an x value. Now this x value is going to be my next iteration, so that I'm going to call x sub 1. So this is going to be x sub 1, and this guy right here, this guy is actually going to be 0, because now I'm looking for the x-intercept. And so if you solve for x sub 1 here, you would get x sub 0 minus f of x sub 0 over f prime of x sub 0, just by doing a little algebra. And so this is going to give you the next x value, and so then obviously you just keep doing that for x sub 2. Well, you're going to do exactly the same thing, but instead of x sub 0, now you're going to use the next x value, x sub 1 minus f of x sub 1 over f prime of x sub 1. And so on and so forth. And so that's where this formula comes from. Okay, so let's actually an example. So we're going to do this function right here, the one that we've been using. And so you always start off with a guess. So your first guess is going to be x sub 0. So let's use 1. And so then just plug it into the formula. So we're going to get x sub 1 is equal to, I'm going to write out the formula, x sub 0 minus f of x sub 0 over f prime of x sub 0. Okay? And this is equal to x sub 0, which is 1, minus f of 1 over f prime of x of 1. Okay, so to actually do this, well, this is our function. So we need to actually find the derivative. So let me do that right here. So f prime of x is equal to 5x to the 4th minus 1. Okay, so then that means that f of 1, if I plug in 1 into here, I would get negative 1. And f prime of 1, I would plug 1 into here, which would give me 4. So this is 1 minus negative 1/4, or 1.25. So this right here is x sub 1. This is my first approximation. So then I do another one, and I do exactly the same thing, except that now I have x sub 1 minus f of x sub 1 over f prime of x sub 1. And so this time, instead of using 1, I'm going to use my 1.25. So this is going to be 1.25 minus f of x sub 1 is, or f of, I'm just going to write out f of 1.25. I'm going to have to do that one with the calculator. That's okay. Over f prime of 1.25. And so what we get is, what color should I pick? Okay, lavender. All right, so what we get is, when we plug this guy in, we get 0.801757, a whole bunch of stuff. Okay, and then when we plug this guy, 1.25, into the derivative, we get 11.207, blah, 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 a bunch of stuff. And so for x sub 2, x sub 2, we get 1.178. I'm just going to round it to 2 decimal places. And so this, you would repeat it until you get to as many number of decimal places of accuracy that you would like. If you do this enough times, you'll get that it's actually, let me do, so this is actually around 1.1673, and so on and so forth. So this is what you would be striving towards. So if you find x sub 3, you would get closer to that. And that's it.